Hey everybody, Mr. Odom here, and I am going to talk to you today about how do you find the surface area of a prism. And we're going to focus on two different types of prisms. We're going to be looking at the rectangular prism and the triangular prism. So what you'll need for this video is pencil, composition book, or note paper to take notes, and a calculator. And the learning target for this lesson is hopefully at the end of it, you will be able to say confidently that I can find the surface area of prisms, specifically rectangular prisms and triangular prisms. Okay, and if you don't feel confident, you can watch the video again and again and again. So let's get started. So basically, the surface area, and we use capital S to represent the surface area, of any prism is the sum of the areas. And remember, area is always the units, I should say. So the units for area are always squared. So remember that. Sum of the areas of the bases and the lateral faces. That's how you find the surface area. So it's a sum. So it's an addition problem. And basically all you're doing is you're finding the areas of all the faces, and you're just adding them together. So the lateral surface area of a prism is just the sum of the areas of the lateral faces. And I have an example down here. I've got a box. So on this box, I have how many faces are there on this box? So let's count them. So there's one on top here. If there's one on top, then there's got to be one underneath on the bottom. There's one over here. If there's one over here, then there has to be a face over here that you can't see. And then there's one in front, and there has to be one in the back as well. So rectangular prism has 6 faces. So last year in the 6th grade, when you went over surface area of rectangular prisms, you used a tool called a net. And this is an example of a net. So it's like taking this box and cutting it along its edges and laying it flat on the ground. So it's taking this 3-dimensional or 3D object and turning it into a 2-dimensional or 2D object. And all you had to do last year was find the area of all 6 of these faces and then add them together. We're going to do the same thing, only this year for rectangular prisms, there's a formula that you can use. And basically, it is right here. So the formula for the surface area of a rectangular prism is you take the bases, which are here, you find the area of them, and then you take the lateral faces, find the area of those, and add them together. So if we were going to look at our box for a second, typically the bases, think of as you sit the box on the floor or on the ground, that face that's on the ground, that's going to be a base. And then you look at the other face that's opposite of this one, which would be this face up here, and this would be your other base. Okay, which means these faces, 3, 5, 4, those would be your lateral faces. So if I wanted to find the lateral surface area, I would just find the area of these 3 faces and add them together. If I want to find the surface area, then I need to find the area of all 6 of the faces. Okay, so I could write this formula if I wanted to find the area of just the lateral surface area. You'll see me use this LSA. and I just want the area of the lateral faces. So then I would take 2 times the length times the height plus 2 times the width times the height. Okay, so let's see how these two formulas work in this problem below. So find the surface area and lateral surface area of this prism, which is a rectangular prism. So this face that's on the bottom represents a base. So then this face on top is also a base. Okay, so our formula tells us to take 2 times the length times the width, and then I want to add that to 2 times the length times the height plus 2 times the width times the height. So here's one of the things that I like to do is I like to label these measurements. So I'm going to call this one my length. This one I'm going to call my width. And this one I'm going to call my height. Okay, so by doing that, I can now make sure that I put the right numbers, or I can ensure that I put the right numbers into the right part of the formula. So this is 2 times the length, which is 2, times the width, which is 3, plus 2 times the length, which is 2, times the height, which is 4, plus 2 times the width, which is 3, times the height, which is 4. Okay, now it's just a matter of simplifying everything. So my surface area is 2 times 2 is 4, 4 times 3 is 12, plus 2 times 2 is 4, 4 times 4 is 16, plus 2 times 3 is 6, 6 times 4 is 24. So my final answer, my surface area will equal 52 feet squared. Remember, area is always squared. So 52 square feet of surface area. So typically students don't have a hard time with using this formula. Okay. This is rectangular prisms. Typically students understand how to do those. It's pretty straightforward. I do recommend that you label the length, the width, and the height, and that will help hopefully ease the confusion when you're putting the numbers into the formula. Okay, so let's move on. Let's look at triangular prisms. Okay, so here's a couple examples of triangular prisms. We have a box here. We have a Tupperware container. Maybe you can put a piece of pie or cake. I love chocolate cake. Anyway, it's not the point. And so the difference between a triangular prism and a rectangular prism is a triangular prism, your bases are triangles. Okay, the bases are triangles. So let's see if we can find the bases. So in this box, this would be a base. Let me use a different color because that's probably not a good one to use. So let me use this. There you go. That is a base. And then the other base would be on the other side back here. That's where the two triangles are. For my Tupperware, my base would be here. Here's a base. I'll write the word base. Bases. Here's one of my bases. And then on the bottom, there's the other base. Notice that in a triangular prism, the bases are always triangles. So just because this box is sitting on another shape that's not a triangle, it's a rectangle, the bases are always triangles in a triangular prism. Okay, that's what makes it a triangular prism, is because of the bases that are triangles. Okay, so question for you. In a triangular prism, how many total faces are there? So the total number of faces. Let's see, total number of faces. What is that? Well, you can count them right here. If I look at the net, so here's a net of a triangular prism, of this triangular prism. And so I can count them. There's 1, there's 2, there's 3, 4, and 5. So there are always going to be 5 faces in a triangular prism. So in that triangular prism, how many of those faces are triangles? So how many faces are triangles? Okay, it's pretty easy to see from the drawing that there will always be 2 triangles in a triangular prism. Okay, so let's look at the formula that we're going to use. The formula to find the surface area of a triangular prism is, first I have to find the area of the bases. And what are the shapes of those bases in a triangular prism? That's correct. They are triangles. And remember, that's 2 triangles we have to find the area of, plus the area of the lateral faces. So let me go back up here. So for my lateral faces, which would be 3, 4, and 5, what are the shapes of my lateral faces? That's correct. Those are rectangles. Okay, so those will always be rectangles. So the bottom line is I'm going to find the area of 2 triangles. So I find the area of a triangle plus the area of a triangle plus the area of a rectangle plus the area of a rectangle plus the area of a rectangle. Okay, and I can put little A's in here to represent the area. Since my triangles are so small, I'll put an area down here to represent those areas. Okay, so this is how we will find the area, surface area, sorry, of a triangular prism. So let's look at a couple of examples. So for the first one, what I want to do is, so the formula is area of the bases. So I always like to shorten things. So I use AOB, area of the bases plus the area of the lateral faces. Okay, so for the area of the bases, the AOB, remember those are triangles, and these happen to be right triangles. Okay, and what are the measurements? So if I find the measurements of one of the triangles, I've found the measurements for the other one. So I look here. Looks like the base is 5 meters for both of these, and the height would be 12 meters. And I see that here. So here are the 2 triangles I'm talking about. This triangle, and then this one down here. Okay, so those are my bases. Can I find the area of those? Yes, I can. You guys remember how to find the area of a triangle? Area equals base times height over 2. So 12 times 5 divided by 2, which equals 30 meters squared. And I have 2 of these triangles. So the area of the bases, the actual area of the bases, equals 60 meters squared. Okay. Now the area of the lateral faces. All right. There are, let's see, 3 rectangles. So let's find the area of those rectangles. Get a different highlighter. So one rectangle's back here. One rectangle's back here. And then we have the one that's in the front. Okay, so the area of the lateral faces, well, I have these 3 rectangles. One of them has a side length of 5 meters by 3 meters. So this would be, let's see, 5 by 3. So that area is 15 meters squared. Okay. I also have this other rectangle here, which is the blue one, which is 3 meters by 12 meters. So 3 meters by 12 meters. So the area of this is 12 times 3, which is 36 meters squared. And then I have one more rectangle that's in the front, which is also 3 meters by 13 meters. Notice how I label my rectangles. That just helps me to keep things organized. So this is 39 meters squared. So my area of my lateral faces is equal to 15 meters squared plus 36 meters squared plus 39 meters squared. And what do you get when you add all that together? That's correct. You get 90 meters squared. So that's the area of the lateral faces. So that doesn't answer the question. What question this does answer is this: the lateral, the area of the lateral faces. Remember, that is the same as the lateral surface area. So the lateral surface area is 90 meters squared, but the surface area way back up here, surface area equals 60 plus 90, which is 150 meters squared. So this is the surface area. Okay, that is the surface area of that triangle. Okay, so hopefully that seems like a lot of work, but a lot of this is to help you keep things organized. Okay, let's look at one more problem. So I have this triangular prism, and I want to find the surface area, which is the area of the bases plus the area of the lateral faces. Okay, so let's start off with area of the bases. And I have 2 triangles. I'm just going to draw one triangle. And then what I like to do is say, well, that doesn't even look like a triangle, Mr. Owen. What's wrong with you? All right, let's try to draw a good triangle here. All right, right triangle. And what I like to do is in parentheses, I'll put times 2. And what that does is remind me that when I find the area of this triangle, I'll multiply it by 2, and that will give me the area of both triangles, the one in the front and the one in the back. So the base of this triangle is 3, the height is 4, and that's centimeters, not meters, centimeters, 4 centimeters. So area equals base times height over 2. That's for a triangle. 3 times 4 over 2, which gives me 12 divided by 2, which is 6 centimeters squared. Okay, 6 centimeters squared. And I have 2 of these triangles, so I multiply that by 2. So the area of my bases is 12 centimeters squared. So far, I'm doing good. I got this part. All right, for my lateral faces, there are 3 rectangles. 1, 2, and 3. So let's look at the one that's on the bottom, this one first. That one is 3 centimeters by 4 centimeters. So the area is 12 centimeters squared. Okay. And this is, I'm trying to find my AOL, area of the lateral faces. The rectangle that's leaning over here, that one is, what is that? 5 centimeters by 4 centimeters, and 5 times 4. So the area here is 20 centimeters squared. And then I have this face here that you can see, and this one is 4 centimeters by 4 centimeters. And so the area there is 16 centimeters squared. So my AOL, area of the lateral faces. Also think of this as your lateral surface area. Okay, that equals 12 plus 20 plus 16, which gives me an answer of, what do I get, 48 centimeters squared. So this is 48 centimeters squared. And so you add these together, and your final answer is 60 square centimeters. So this is your surface area of this triangular prism. Okay, so it looks like a lot of work. Typically, students don't like to, they tell me, oh, it's a lot of work, Mr. Odom, but the reason I do the work is to help keep things organized. I find that students that try to rush through these problems tend to make a lot more errors than those that take their time and keep track of all the different faces and the areas of those faces. Okay, so today we learned about how to find the surface area of prisms. The next lesson will be the surface area of pyramids, okay, which is very similar. So I hope you guys got something out of this video, and that's all I have for now. It's Mr. Odom. I'm out.